A part model frequently needs features that either are more complex than your typical extrusion or revolution, or can be more simply created using other tools. Taking a look at the model, we see we have a few sketches on the screen. The first we'll address is the text. We'll use the Emboss tool to select the text and then give it a thickness that we want above the model. We'll set the direction and tell it to join the geometry. What it will do is create text to that thickness following the contour of the geometry. Similar to an emboss, we can use the decal tool to take an image and have it apply it to a face. We can have it chain across multiple faces, then we can select the face that we want to apply it to. Clicking OK will project that image onto the face. Finally, using this single line sketch, I want to define a rib. Ribs can work in a few different ways. Ribs can be defined either normal to the sketch plane or parallel to the sketch plane. Selecting parallel to the sketch plane, we'll choose the profile and set the direction. Immediately we get a preview of the feature. We can set a thickness for the feature. We can also create a finite rib that has a limited thickness or have it fill to the body that's available. To round out the rib, a specialized fillet tool works perfectly, the three-face fillet. Selecting three faces, it will generate a fillet that goes across all of them. Now that we've developed our solid model, we can save it and create a new component. This new part we'll be creating will be a machined version of the arm. Rather than beginning to sketch and create new features, we'll derive the body of the existing arm. Derive has many different options. You can derive in the solid body, as we intend to for this exercise. You could derive in surfaces. You can even just derive in sketches, or just the parameters or work geometry of the model. For workflows like castings, bringing in the body and then being able to generate machined versions is a great application. To do this, I'll start a new sketch. On the XY plane, define the profiles that I want to use for my machined distances. For this boss, I only need machining on one face, so I'll apply a dimension to make sure it's located correctly. And of course, we could completely detail the sketch for all of the profiles. But for a quick example, we'll take these profiles, finish our sketch, and use the Extrude tool to select the three profiles, do a symmetric feature that is cutting. This will replicate our machined features, maybe add a couple of holes, and let's just add a clearance hole for a bolt in the back. Have it go all the way through. Great. So now we have our machined component. We have three machined faces and two holes. Of course, the issue with castings and the value of using derived components for castings and for other workflows where you have a model, a series of parameters or sketches that can be used as a starting point for a new model, but you want to maintain a connection to the original, that's what Derive is best at. So returning back to the casting, making a quick modification to the sketch, setting it out to be a little taller, maybe making it a little longer. We'll update the solid model we'll see that the text remains wrapped around that face and everything is updated properly. We'll save this model and then come back to our machined part. Now imagine that there's any number of machined parts derived from the solid. Every time you open one of them, you just simply update the casting that it was based on, and the part is updated. Then, any drawings or any other assemblies that those machined parts are in will also be updated as you edit them.